So what we're going to do now is use a diagram to show that x times, in parentheses, x plus 3 is equal to x squared plus 3x. So if I were to draw this, on the outside, I'm going to draw that as my length. And then this piece right here, I'm going to draw as my width. So my length has one portion. And in here, this has two pieces to it. So I would cut this into x and 3. So now to find the area on the inside, x times x is x squared, and x times 3 here is 3x. So that just showed x times x plus 3 is x squared plus 3x. If you're given this in factored form, here's a standard form equivalent. Now, one thing that you can do for standard form, if you have x squared and 3x, you can write those as the area of two rectangles, and then you can break it out to try to make these pieces. Well, if this is x squared, out here we would have to have x and x to make x squared. And then for this rectangle, if I took 3x and divided it by the x piece that I know, this would have to make x there. So then if I thought, well, here's the standard form, and on the outside, how do I make that work? One thing that I do is I put the plus 3 and kind of put my parenthesis on the outside. So here, this kind of showed the idea of factoring, that x squared plus 3x is equal to x times x plus 3. So now what we're going to do is show that x times x plus negative 6 is equal to x squared minus 6x. Well, what I'm going to do is use the idea of factoring. So let's say we had x squared and minus 6x. Well, out here, I know that these pieces have to be x and x. And then if I take negative 6x and divide the x out, negative 6 goes on the top. So then I would know here that x squared minus 6x, remember this is standard form, is equal to x times x minus 6 in factored form. Now this piece is a little bit more complicated, so I'm going to show it twice. So here's the length, here's the width. So to draw my area model, we would have x and 2. So I draw in a rectangle, and I put it like that. And then for my width, I would have x and then 4. So this would make x. X times x makes x squared. 4 times x is 4x. 2 times x for this rectangle is 2x. 4 times 2 is 8. So here you would have x squared plus 4x plus 2x plus 8 is x squared plus 6x plus 8. So again, this is factored form. This is standard form. Now, if we were to try to do this piece where we start with standard form and move to factored form, one thing that I would know here is only two pieces of information. So I would know here the x squared piece goes here, and here I would know the 8 piece goes there. But I would know that these two pieces have to add up to be 6x. So I would have x, and I would need two multiples of 8 that add together to make positive 6. So if I think about that, well, it couldn't be 1 and 8. So then I might think, all right, well, 2 and 4. Well, here, if I put 2 here and 4 here, 2 times x is 2x. 4 times x there is 4x. Adding that, you would have x squared plus 6x plus 8. So you can see your factors on the outside. You have x plus 4. And then here, this would be x plus 2. So this we just showed in factored form, x plus 2 times x plus 4 is x squared plus 6x plus 8. So we're going to use that idea here. Can I take standard form and move it into factored form? So we know what our answers has to be, but we can show with a model why that has to be. So I know that I'm going to have 4 pieces to the model. My x squared piece has to go here in the upper left-hand corner, and my number piece has to go here. Now these are going to be x pieces. We have to figure out, well, what factors of 40 add together to make 14. So we can start here. Well, x times x is going to make x squared. So 2 things that multiply to 40 and then add to 14. Well, in my head, I'm thinking 20 and 2. 20 times 2 is 40, but 20 plus 2 is 22. So what about 4? 4 times what is 40? So I think, well, maybe 4 and 10. So 4 plus 10 is 14, and that's what we need. So this would be 4. This would be 10. Multiplying them, 4 times x is 4x. 10 times x is 10. So this, in fact, if I kind of draw that here, around there, and around there, we would have x plus 4 times x plus 10 is equal to x squared plus 10x, or really just plus 14x. We can add those together, plus 40. So we can do some other ones too. What if we had 2 negative numbers? So really this x plus negative 5, no one writes it like that. They write x minus 5 and x minus 1. Why write 2 operations when you can just write 1? We can show that that is going to equal in standard form x squared minus 6x plus 5. So I'm going to work with the idea of factoring. So in here, we know that we would have x squared in the upper left, and then my number here would be 5. So right away, I know this has to be x and x. But now we need factors of positive 5 that add together to be negative 6. Well, the only way I can multiply 2 numbers together and have them be positive, and the sum is negative, is if both of them are negative. So this has to be a negative, this has to be a negative. The only numbers that are going to multiply together to make 5 are 1 and 5. So to show that works, negative 1 times x is negative 1x. You can just write negative x too, either is fine. And this should be a 5, I miswrote that. So negative 5 times x is negative 5x. Then if I add that, that makes x squared minus 6x plus 5. So then our last piece here, we have x squared minus 8x plus 7. So if I'm looking at that, I'm going to draw our area model. I know that x squared goes here. So you would have x and x. I know that positive 7 goes here, but my 2 numbers are negative 8, or they have to sum to be negative 8. Well, if I multiply 2 numbers together and they're positive, but they add to a negative, they both have to be negative. So this is a negative, this is a negative. The only way to multiply to get 7 here would be if this is negative 1 and this is 7. So this part here would be negative 1 times x is negative 1x. Here, negative 7 times x is negative 7x. So then this, we would have, if I put parentheses there, x minus 7. Here, x minus 1. Again, factored form, and then this would be standard form. So we did kind of observe that. So each of these parts were the sums of 2 differences. How is each expression in factored form related to each in standard form? Well, we just showed the inside, you can split up the x terms in standard form to put on the outside factored form. So basically what we can say is the factored form is the length and width of the outside of the rectangle. And then standard form is the inside of the rectangle.